Wire Monkeys, welcome to another episode of Let's Talk Cabling. This week, we're talking about grounding electrodes.
Welcome to Let's Talk Cabling, the award-winning podcast where knowledge is power and the low-voltage industry connects. Hosted by Chuck Bowser, RCDD, we're here to empower installers, designers, and industry pros with the tips, stories, and best practices you need to stay ahead. From copper to fiber, standards to innovation, this is the show that keeps you plugged into success. So grab your tools, turn up the volume, and let's talk cabling.
Welcome to the show where we tackle the tough questions submitted by installers, estimators, technicians, project managers, customers, even ICT personnel. We are connecting at the human level so that we can connect the world. If you're watching this show on YouTube, would you mind hitting the subscribe button and the bell button to be notified when new content is being created? If you're listening to us on one of the audio podcast platforms, would you mind leaving us a 5-star rating? Those simple little steps helps us take on the algorithm so we can educate, encourage, and enrich the lives of people in the ICT industry. Wednesday nights, 6 p.m. Eastern Standard Time. What are you doing? You know I do a live stream on TikTok, Instagram, Facebook, LinkedIn, and a bunch of other places where you get to ask your favorite RCDD, and you know that's me, questions on certification, installation, design, project management, even estimation. But I can hear you now, but Chuck, I'm driving my truck on Wednesday nights at 6 p.m. I don't want to get into an accident. Relax. I record them, and you can watch them at your convenience once you get home. And finally, while this show is free and will always remain free, would you mind clicking on that QR code right there? You can buy me a cup of coffee. You can schedule a 15-minute one-on-one call with me, after hours, of course. Or you can even purchase a Let's Talk Cabling or Estimator t-shirt from Amazon. So the day has come where I've started to do some work on the podcast studio. You might have already noticed a little bit of different surroundings. My LED light works too, but it causes interference with the camera. I got to clear that hurdle. But this weekend, we installed a new grounding electrode for the podcast studio with some help. I had some friends from Wilson Technologies come over and help me. So I decided I was going to do a show on grounding electrodes this week because that seems to be an issue that a lot of people just don't thoroughly understand. So let's talk about the grounding electrode. That's the rod that you drive into the ground. That's the ring that you bury in the earth. It could be a ground plate. It could be lots of different things. Most commonly, what you're probably going to do is install a ground rod or have somebody install it for you. Now, like anything else, there's always a way you can do it by code or you could do it by the standards. So you're going to find everything you need to know about ground rods as far as the NEC is concerned in NEC Article 250. It's going to tell you that you got to drive that ground rod into the earth. It's got to be copper clad. It's got to be 5/8 inch, or it could be half inch if it's UL rated. And you're going to drive it into the ground, and then you're going to measure it. And it should be 25 ohms of resistance or less. See, when you drive that ground rod into the earth, it's making contact with what's called the shells of influence, or the sphere of influence. Think of concentric rings, each one a little bit larger than the previous one, and what happens is the ground voltage will go into the ground rod, it'll safely dissipate into the earth. The ground ring and the ground plates, the other types, you probably won't be installing. So you might be wondering, what if I can't get 25 ohms or less? Well, per code, you have to drive in a second rod. But you don't have to test it, which is kind of ironic. You have to drive in that second rod. That second rod's got to be, I think, 6 feet away from the primary run that you put in, that you installed. And then you got to test it with an earth resistance tester. You can use a 3-point or a 4-point earth resistance tester. Now, I happen to have a 4-point earth resistance tester somewhere here in my shop. I'm not sure where it is. I ordered one just to put in the ground rod, but it didn't come in time. So I had Wilson Technologies come and actually help me install that ground rod. So let's watch this video that we took of them actually installing the ground rods.
Hi, I'm Chuck Wilson with Wilson Technology Group. We're a local Brooksville-based integrator, and out here today working with Chuck to talk about bonding and earthing for a new building. I've sit on several of the committees with Bixie. Been a Bixie member and served on Bixie board, served on many committees since 1992. I currently chair one of the manuals, the N1, N2, and N3, and I also in chair of the Bixie Smart Building TIA or ANSI TIA documents. Been in the industry for longer than I really care to tell anybody about. But basically I started in the industry right out of high school working for a local phone company. Love the work and like being a part of an industry that's constantly changing and growing.
Hi, this is Andrew over here in Brooksville, Florida. Wilson Technology Group. Shout out 2 years in working with Bixie and working with Chuck here and both Chucks, and definitely learning some new and interesting things. Previously worked with Verizon Wireless since 2011, tech support, but definitely wanted to see how we can incorporate AI into using technology and low voltage, and that is where Wilson Technology Group is headed, into the future and beyond with AI.
Let's take a short break. Are you looking to grow your low voltage business? At Bowman Vision Media, we don't just market to the low voltage industry. We come from it. With decades of experience, we uniquely understand your business and how to help it grow. From social media to content creation, we deliver marketing that works as hard as you do. And while you're leveling up, check out the 49 Volts podcast, your go-to source for industry insights and expert interviews. Visit bowmanvisionmedia.com to learn more and subscribe to the 49 Volts podcast on YouTube or wherever you listen.
We're going to be setting up a ground rod for this new building. We're starting out with an 8-foot rod. It is copper cladded. It is UL listed. And we will pound it down into the ground. We're fortunate enough that we're on a combination of clay and sand, so driving it into the ground is not going to be terribly difficult. There are devices that will go on a hammer drill, such as a Hilti or a Milwaukee or any of those, a Bosch big hammer drill, that will drive it even into coral. So again, it's you see the steel, you see the copper cladding. The rods are copper cladded because they use the steel for the strength to be able to drive the rod into the ground. Copper's a fairly soft metal, and so having a ground rod that's 8 foot long wouldn't drive in a lot of areas. Also, they do make a ground rod when your environment is suitable. You can get by with a 6-foot rod. You can, in some areas, you're looking at ground rods that are 12 foot. So it has to do with how good the ground earthing is around the facility. You also, too, in some instances where it's all sand, you may have to run a PVC pipe that has holes in it down into the ground at your 8-foot depth and fill it full of diatomaceous earth, and then drive your ground rod into that sleeve. Downside is occasionally it has to be evacuated and redone because the diatomaceous earth will break down over time.
And the C is not French.
This started out as an 8-foot rod. Keep going. That's good right there. How well or how strong the ability to earth with this ground rod. So we have a device, sometimes referred to as a megger. This particular item is an AEMC. It's a French-built product, but pretty much works the same as a megger would work. That's the distance I need. It's an 8-foot rod. Okay.
Gamut 50. Pull it back. All right, pull it back a little bit.
X to Y, high resistance. So, but you don't have any noise in the ground. The noise would happen if you had a lot of bleed over from adjacent power lines buried underground, where there's a lot of noise being picked up. So your resistance is and you don't have any X to Z fault. So you've got a consistent capability in the earthing. And that's pretty much it.
How many ohms was it?
One.
1 ohm? Hey, you don't get better than that. So now that we got that ground rod installed, we have to run a conductor, a number 6, from that to my primary bonding bus bar. You see, as long as that conductor, the TBC, is less than 20 feet, the number 6 is fine. So I'm going to mount that or attach it to my primary bonding bus bar. It's going to be at least 4 inches tall, 1/4 inch thick, however wide it needs to be. It will be isolated from its mouth. You're going to scratch it, use antioxidant, and use antioxidant and attach that 2-hole connector to the lug. That's going to be another episode because we didn't get that far today. And I still got to mount the wall that this is going to mount on. Now, when you're driving in the ground rod, the soil composition matters, right? It does. If it's dry, you're not going to get as good contact. If it's wet, you'll get a better reading. If it's clay, you'll get a better reading. If it's sandy soil, you're going to get worse readings. Now, you can actually prospect the ground by using a 4-prong earth maker. And prospecting will tell you how you can get that, what reading you can expect to get out of that. Also, a 4-prong measurement is going to tell you if there's anything metallic in the ground. You see what you do, you attach one lead to the tester to the ground rod, or to the T-post that's acting as a ground rod. Another one that's going to be out, and how far out depends on how deep you go with your rod. And then another one you're going to place at 52% of the distance, and then you're going to test it, go to 62%, test it, and then go to 72%, and then test it. And when you look at those 3 values, if you can plot them out, they should be a nice flat line on your curve, and then it should go up. You see, if those values keep increasing, that tells you that there's something metal in the ground underneath of you. It could be anything, but the most dangerous thing that it could be is a buried electrical conduit. Because you drive a ground rod into a buried electrical conduit, you are not having a good day. And you're going to be visiting a hospital. But where I put in my podcast studio, I know there's no electric up there. And then we tested it. And we actually got a 1 ohm resistance. So we're far below the 25 ohm resistance, which is required by code. Now standards, they're going to tell you that it's got to be 5 ohms or less. The lower the number, the better connection you have to the earth. Now a lot of people misunderstand the reasons for a ground rod for a telecommunications bonding and grounding system. It's not for a ground fault. It is for lightning strikes or some kind of a high energy current to make sure that stuff gets dissipated safely to an earth so property doesn't get damaged, equipment doesn't get burnt out, and people don't get hurt. Now ground rods, they really should be inspected yearly, looking for things like looseness and corrosion. Good tip for you MSP providers out there. Maybe schedule like how the HVAC people do, because our HVAC is going out on the house. And so you can have packages where they come out and inspect it once a year. Why not do the same thing with the telecom bonding and grounding system with your customers? Because it is a life safety issue, not a performance issue. You do also have to pay attention to other electrical things near you and radio towers near you. Now, the property right next to me, the guy used to have a ham radio tower mounted there, but he took it down about 2 months ago. So like I said, we had a nice clean reading for the shop. If you don't do the 4-prong test or the prospecting method, you can use a 3-prong earth resistance tester. Now, I gotta tell you this, an earth resistance tester is like a voltmeter, but it's different. It has extra filters to filter out the unwanted frequencies that you don't want to have rolled in with that measurement. So you can't just use a volt-ohm meter. Although they do have clamp-on devices, but they're not going to be as accurate, and quite often you'll get a ground loop included with that, and you really don't know what's going on with it. So the best way to test an existing ground rod is called the fall-off potential method, using a 3-prong earth resistance tester. So I know this is a short video, but it was done kind of last minute. And now you'll know how to install a ground electrode if you ever get asked to install one. If you still don't feel confident or that you know enough information, then hire an electrician or professional to install one for you and have them make the connection to your primary bonding bus bar. So make sure you stay tuned over the next couple of months as I work on the podcast build out series. We'll be putting up 3/4 inch AC grade ply. We'll be putting in anti-static flooring. We'll be putting in cabinets and racks and 66 blocks, 110 blocks, all kinds of stuff coming into the new podcast studio. So make sure you stay tuned. And if you have any questions about it, make sure you put them in the comments below. Until next time, knowledge is power.
Thanks for listening to Let's Talk Cabling, the award-winning podcast where knowledge is power and the low-voltage industry connects. If you enjoyed today's episode, don't forget to subscribe, leave a review, and share it with your crew. Got questions or ideas for the show? Chuck wants to hear from you. Stay connected, stay informed, and always aim for excellence. Until next time, keep those cables clean, your standards high, and your future bright. Let's talk cabling, empowering the industry one connection at a time.